Assalamualaikum and hi, my name is Nur Shahza Akila binti Abdullah Suhaimi. I am from 3 SSCC. Today, I want to talk a little bit based on my reading from the Journal of Optimization of Instrument Condition for the analysis for the mercury, arsenic, antimony and selenium by atomic excitation spectroscopy. Based on my reading, in the abstracts, I have learned that the chemical vapor generation of atomic absorption spectroscopy technique is the most popular for trace analysis, specifically hydride generation continuous flow system for arsenic, antimony, and also selenium. But cold vapor atomic absorption spectroscopy is used for the mercury. Second, instrument parameter hydride generating reaction was improved sensitivity and reliability of the result. The advantage that we get is can increase the production of hydride or vapor species formed by improved recoveries. Second, it also help to reduce chemical interference from other species that may compete with analyte of interest hydride formation. The parameter that can optimize is reagent flow rate, sample flow rate, argon flow rate, concentration of reagents, and also read delay time. Then, flow rate, reagent, and sample are affected by tension of peristaltic pump and also size of tubing. Optimized read delay time for mercury is 70 seconds, while 20 seconds for arsenic, antimony, and also selenium. Argon flow rate for arsenic and antimony is 0.2, while for mercury and selenium is 2.0 mil over min. Then, we talk about the method that we use, which is hydride generation atomic absorption spectroscopy and also cold vapor atomic absorption spectroscopy. For the hydride generation atomic absorption spectroscopy, we use the separation of analyte from the matrix by conversion to volatile the hydride. It also cannot determine by conventional method. Technique that we use, which is hydride generation and release element interest from sample solution with aid of reducing agent. Second, hydride collection, and also third is atomization transport of released hydride to atomizer by flow of an inert purge gas. The factors that influence yield of hydride and sensitivity technique is concentration of acid, concentration and type of reducing agent, flow rate carrier gas, flow rate reducing agent, and also flow rate of acid. And lastly, it was also the rate delay time of the sample. Then, we go to cold vapor atomic absorption spectroscopy. It was used for mercury because it was the most sensitive to measure or determine of the mercury. The reducing agent that we use is the stannous chloride, which is can use to convert ionic metal ions of mercury 2+ to mercury 0, which produce high analytical absorbance signal. Then, mercury also have higher vapor pressure liberated and also entrain inert gas of argon after produce liquid gas separation. Third, mercury also have the vapor transferred into particle path or of atomic absorption spectroscopy, where the mercury absorb light specific wavelength of room temperature. factors and sensitivity that can influence higher supply rate of gaseous mercury is: one is concentration of reducing agent. Second is flow rate of reducing agent, which is stannous chloride. Flow rate of the sample, flow rate of the purged gas, and also delay time. From the discussion, we get that optimized instrumental condition was superior recovering when use of measure of volatile and also hydride producing metal. Reductant concentration had important influence on signal intensity because it can affect hydride generation process and also can converting oxidation state from the lower oxidation state, which is can make the element more stable. For example, mercury 2 plus to mercury 0, which is the stable vapor. Arsenic 5 plus to arsenic 3 plus. Antimony 5 plus to antimony 3 plus. And also selenium 6 plus to selenium 4 plus. Then, reduced ion form the stable hydride needed for hydride generation atomic absorption spectroscopy, which can produce by reaction with appropriate reducing agent. Optimized reducing agent for selenium is 0.1% weight over volume in 0.5% of sodium hydroxide, while for antimony and arsenic is 0.6% of weight over volume for sodium borohydrate in 0.5 weight over volume of sodium hydroxide. It was efficient reducing agent of mercury in stannous chloride. Antimony and mercury was used to increase the concentration of reductant, achieve better signal intensity. While for arsenic and selenium, it was a greater signal noise produced when it's increased in concentration of sodium borohydrate. Vapor generation indicate higher concentration reagent. Hydride generation process occur more rapid. Other than that, elevated acid concentration was produce larger amount of hydrogen gas can dilute hydride. Other than that, mercury and selenium produce the higher signal with higher flow rates of argon compared to arsenic and antimony, where dilution of hydride excess argon occurred. Then, it was effectively removed adherence ion, appropriate flushing time needed between the sample. Flushing time can be controlled by instrument delay time. Longer delay time, more flushing time can occur. Delay time optimized to ensure that possibility of memory effect was eliminated. Arsenic, antimony, and selenium produce a maximum signal at lower delay time of 20 seconds, while mercury required longer delay time up to 70 seconds to eliminate memory effect. That's all from me. Thank you.